Alright, hello everybody. Today I'm going to be working through the AP Calc BC FRQ number 6 from the 2011 exam. If you're not familiar with the layout of the exam, usually the 6th FRQ is a power series FRQ or a Taylor series type question, and so this is the case for this one. So without further ado, let's get into it. I would also like to mention that I have the FRQ open in front of me. And so if you want to follow along, I would recommend just Googling 2011 AP Calc BC FRQ number 6. This is Form A. So let's get started. So the first question is write the Taylor series, first four terms of the Taylor series for sine of x. So this is one that you're just kind of expected to know. The first term is going to be x minus x cubed over 3 factorial plus x to the 5th. 5 factorial minus x to the 7 over 7 factorial. Now part of the first part, it also asks for this Taylor series for sine of x squared. Now, you can just use the Taylor series we just made, but replace all that x's with x squared, and you'll get the Taylor series for sine of x squared. So this is x squared minus, so if replacing x with x squared, you get x to the 2 to the 3, which is x to the 6. Plus x to the 5 to the x to the 2 to the 5, which is x to the 10. That says 14. So there's our answer for part A. Now in part B, it asks us to write the Taylor series for cosine x, and this is another one that you're just expected to know. So it's 1 minus x squared over 2 plus x to the 4th over 4 factorial minus x to the 6 over 6 factorial. Alright, and then the second part is a little more complicated, but it asks you to combine the cosine of x and the sine of x squared to write the Taylor polynomial for f of x. And by the way, I probably should have written this earlier, but f of x, see this? F of x is equal to sine of x squared plus cosine x. So we want to combine this Taylor series and this Taylor series to make that. Okay, so the first term, is 1. Now we have in the sine of x we have an x squared term. In the sine of x we have an x squared term. But in the cosine of x we have x squared over 2. So we have x squared minus x squared over 2, because that's a positive x squared. Now we need to get a common denominator, so we get 2x squared over 2. And then if you subtract those, you get positive x squared over 2. So it should be 1 plus x squared over 2. And there's only one. The next term would be x to the 4th. So there's only one x to the 4th term. And then we have to do a similar thing with x to the 6, because there's an x to the 6 in both series. So you have x minus x to the 6 over 3 factorial. See that? And then you're subtracting x to the 6 over 6 factorial. You need to get like a lamp or something there. It's fine. Okay, so 6 factorial is 6 times 5 times 4. 6 times 5 times 4 times 3 factorial, right? So we need to get a common denominator again. So this would be equal to negative 6 times 5 times 4 times x to the 6 divided by 6 times 5 times 4 times 3 factorial, then minus x to the 6 factorial. And the bottom is also, clearly this is just 6 factorial, right? So you get 6 times 5 times 4, I believe, is 120. So you have negative 120 minus 1, so this should be negative 121 x to the 6 over 6 factorial. And it just asks the first four terms, so that's the fourth term. Right? So there's your answer to part B. It's this part. Okay, part C asks for the value of f prime of 6, or sorry, no, rephrase that, the sixth derivative of f at 0. Now, let me move that up, yeah, the sixth derivative of f at 0. So, this f is a Taylor, this series right here is a Taylor series around 0. The center is 0. So the structure of a Taylor series is f of c. The c is the center. So in this case, c is 0 because it's around 0. Plus f prime of c times x minus c. All these c's are just zeros. Dot, dot, dot. Plus the sixth derivative of f of c, which is a 0. X minus c to the 6 divided by 6 factorial. So we're looking for a term, we're looking for the sixth degree term in the f of x series we just made, and that will let us know what the sixth derivative of f of x at 0 is, right? So looking here, if we replace all the c's with the zeros, because it's around x equals 0, you get f6 of 0, the sixth derivative of 0, x minus, so x to the 6 over 6 factorial. And now we can kind of match this term with this term right here. So it's negative 121 x to the 6 over 6 factorial. Now this part is the same and this part is the same. The sixth derivative of f at 0 is equal to negative 121. All right. And then the final part, it says, let p sub 4 of x be the fourth degree Taylor polynomial for f about x equals 0. Using the information from the graph of y equals the absolute value of the fifth derivative of x, show that p sub 4 of 1/4 minus f of 1/4 is less than 1 over 3,000. So this, that was absolute value, p sub 4 of 1/4 minus f of 1/4 is less than 1 over 3,000. Okay, what is this part? This part is the error, right? Because this is your approximation, and this is the actual. So if you subtract their actual from your approximation, it's saying show that the absolute value of that value is less than 1 over 3,000. So basically you need to show that the error, the absolute value of the error, is less than 1 over 3,000. Now, what are we using? We're using this Taylor polynomial right here. Now, as you can see, it doesn't alternate. It's not an alternating series. So we're going to be using the Lagrange error bound. The Lagrange error bound, not the alternating series error bound. All right. So the Lagrange error bound says that the absolute value of E is less than or equal to the absolute value of M. I'll get back to that in a second. Of x minus c to the degree that you're using plus 1. So you're using the fourth degree. So 4 plus 1 is 5. So 5 divided by n plus 1 factorial divided by 5 factorial. Okay. Now m is the greatest value that the n plus first derivative can take on within the interval of x to c, or c to x, whichever one is bigger. Okay, so this question is handy. It gives us a graph of y equals the absolute value of the fifth derivative of x. So we use this to find the maximum value it can take on in the interval that we're supposed to be using, which I'll get to in a second. So using the information in the question, that's how we find m. Now, what are we approximating? We're approximating the value of 1/4, right? So that's going to be your x, and your c is 0. So you're using the greatest value of that on the interval from 0 to 1/4. Okay? Now, based on the graph that we're given, we're not really given any exact value for the maximum, but we are given that it never is greater than 40 on the interval 0 to 1/4. So we will use 40 as m. Okay? So because you need to write because the absolute value of the fifth derivative of x is less than 40 on 0 to 1/4, use 40 for m. All right, something like this to explain why you use that value for m. So now we're gonna just plug in our values. So the absolute value of the error is less than or equal to 40. Absolute value of 40 times 1/4 minus 0 to the 5 divided by 5 factorial. So the absolute value of e is less than or equal to 40 times 1/4 to 5 over 5 factorial. So 1/4 to the 5, because I don't think we get a calculator for this question, but I'm not positive, but I'm pretty sure we don't. So the absolute value of e is less than or equal to 40. 40 is going to stay on top. This is 1 to the 5 over 4 to the 5. So 40 times 5 factorial times 4 to the 5. So absolute value of the error is less than or equal to. So 40 over 120 times, I think it's 1024. So that's 40 over 120 is 3. So that's 1 over 3 times 1024, which is obviously bigger than 1 over 3,000, or sorry, smaller than 1 over 3,000, which is smaller than 1 over 3,000. So therefore, that maximum error must be less than 1 over 3,000. And so that's on this 2011 AP Calc BC FRQ number 6. Thanks for watching.